Right, let's continue. I don't think we did the iterative version of the Fibonacci. I gave you the concept. I told you the concept about it, but we didn't really do it inside the lab. So I'm just gonna do the iterative version now. And I did the factorial with you just for as a refresher, as I told you. We did the factors, so there's no need to do the factors again. So let's take on the Fibonacci iteratively and the prime factors, right? And I believe, as we said, we did the sum events, yeah, and the multiply odds. It's just the same idea. You're just, you change the arithmetic operator. That's it. Okay, so let's take the iterative Fibonacci sequence. Now, the iterative Fibonacci sequence is a little bit easier than the recursive one. The recursive one has been illustrated in the lecture, so that's why I'm not planning in explaining the concept of the recursive one again. Let me just clear this canvas here. Okay, so let's take the Fibonacci iterative. Right? The idea of Fibonacci is that you have a sequence. You have 0, 1, right? You start always with 0, 1. These are the first two numbers. And from these two numbers, you generate the summation accordingly. So the consecutive term after the first, or after any two terms, is going to be the summation of these two terms. So in this case, the consecutive term is going to be 0 plus 1 is going to be 1, right? And 1 plus 1 is going to be 2, and 1 plus 2 is going to be 3, and 2 plus 3 is going to be 5, 3 plus 5 is going to be 8, and so on, right? So this is basically the Fibonacci sequence, right? The idea here is that, actually the idea is the same in the recursive version. You know that you have two numbers, and the third is going to be always the summation. Now that summation in the next iteration of the next recursive call is going to be the second term, right? And the second term is going to be the first term. I know that you don't understand this yet, but just be with me, alright? Bottom line is that in the recursive or the iterative version, the core of the problem, as we discussed earlier, right, is the same, right? But the iterative version is a little bit easier to understand, so I'm just gonna delete this or remove all of this and write the sequence um, without any additions here. So let's say that this is my sequence. Right? And these are my mathematical terms. So this is the first mathematical term, second, third, fourth, fifth, sixth, and finally the seventh. Right? Of course, and so on. So the question would be, what if I told you to get me the nth term, the nth Fibonacci term, right? And I asked you for something like, for example, the sixth term, right? So this is we're gonna get you 5 in this case, right? So that's the whole idea behind the question. Now let's take this and dissect it as if we're taking this in in a loop manner, right, or an iterative manner, right? Let's take the smallest chunks possible. Let's take the first two chunks here, and accordingly, let's start to generate the additions of each two consecutive terms. So let's say that in the first iteration, we're gonna have the 0 and 1. And you should think about this from the start, before you begin the iteration. Like, these are the first two numbers that are the reason for every other addition that's going to be generated afterwards, right? So I can safely assume that maybe I would say something like n1 is going to be 0 and n2 is going to be, or n2 is going to be 1, right? So I'm going to initialize n1 and n2 with respectively 0 and 1, right? So I know that from this first sequence, I should have my 1, and this is going to be my n3, right? So you can say that in the first iteration, I have this 0 and 1, and you know, all of these are addition by the end of the day, right? All of these are addition. So if this is n1 and this is n2, then basically the addition or the summation of both of them is going to give you n3, which is 1 in this case, right? So this is the first iteration. If you look at the second iteration, right, you're going to see that we're going to take the next sequence, which is 1 and 1, right? This 1, which is going to be n2 in this second iteration, was previously n3 in the first iteration. So what was n3 is going to be taken as n2, right? And accordingly, what was n2 in the previous iteration is going to be, let me just write this above here. What was n2 in the previous iteration is going to be n1, right? So what was n2 is going to be taken as n1. And the addition between those two guys is going to be n3, which is in this case is going to give you 2, right? So this is going to be n3 in this iteration, which is 2, right? Now, let's take a look at the third iteration, right? So what was n3 in the third iteration? Notice that this is the sequence that we are working on right now. So what was n3 in the previous iteration is going to be n2. What was n3 is going to be n2, right? And what was n2 in the previous iteration, which is n1, is going to be n1. So what was n2 is going to be n1. And these are going to be added together to give you 3, which is n3 in this case. And accordingly, in the first iteration, what was n3 is going to be the new n2, so in this case 3, and what was n2 is going to be n1, which is in this case 2, right? And this is going to give you n3, which is in this case 5. All right? So we have two main questions here. The first one is, when should, or what are the start point of the loop? Well, this is kind of obvious. If you looked at this, you're going to see that you initialized the sequence with, or you initialized the two variables n1 and n2 with these two variables, with these two values, which is 0 and 1, right? So typically, if I'm looking for the sixth term here, I'm not going to go for a whole number of 6 iterations, right? Because typically these are not going to be counted, but rather I'm going to start from -2 of these iterations. Like if this was 0 and 1, for example, as indices, right, in the range function, or count in the range function, right? I'm not going to start from 0 and 1. I'm just going to start from this part right there, right, which is basically 2. All right, so starting from this number of iteration until my nth term, which is the user is going to enter as an input, right? So instead of running for 6 iteration, I'm going to run for -2. So this is going to be 4 iterations, right? Regardless if you are starting from 0 in the range function or starting from 1 in the range function, and there's going to be an equal sign or addition to the nth term by the end. So the idea is the same, is that if you needed to look for the 6th or the nth term, you don't need to go for n number of iterations. You're going to need to go for n-2 number of iterations, right? So we're going to have from, for example, 2 in this case up to the nth term, right? Or if you were starting from a counter that starts from 1, not from 0, so you're going to start from 3 up until nth plus 1, right? Now the next question is, what is the core of the problem? Or let me rephrase this, what is the smallest subproblem? Well, you can see this clearly, right? So in every iteration, what happens is that what has been calculated as n2 is being assigned into n1. So what is being calculated in n2 is being assigned into n1. That's one part, right? And what is being calculated in n3, which is the summation of both of them, right? So n3 is basically the summation of both of them, right? Is being assigned into n2, right? So that n3 is being assigned into n2. And as a matter of fact, you don't really need a third variable or a third wheel for the addition. You could have just written this in simply one line, right? But I'm just doing this for simplicity, to be clear to you. All right. So let's see how this looks in Velocity code. All right. So let's say that this is iterative Fibonacci, and let's have n1 and n2 with 0 and 1, and let's say that the nth term is going to be input from the user, right? So this is going to be inputted from the user, right? And now my loop is going to start from, instead of starting from 0 or 1, I'm going to skip 2 iterations up until my nth term, right? So let's say that the user is going to ask for the 6th term, which is going to give you 5, right? So now let's say that what we did right there, which is n3 is going to be equal both of them, and n1 is going to be equal n2, and n2 is going to be equal n3, right? And let's try and print all of them when this ends. Let's give this as the 6th term, and this is going to give you 3, 1, 1, or 3, 5, 5. We really need the nth term. So if I looked at this closely, you're going to see that n1 and n2, n1 and n2, n1 and n2, n1 and n2, n1 and n2. So n2 is basically going to be my nth term. So I can actually depend on this, right? So I can just say that the nth term is going to be 5 in this case, which is n2. Now let's see the 7th term. Oops, let's give 7 here. It's going to give you 8. Now there are some stuff that we need to take care of, because if you try to get the first term, you're gonna get 1, which is wrong, and if you try to get the next term, you're also gonna get 1. In this case, the next term is right, but for the first term, this is incorrect. So you can just add an if statement and see if the nth term is equal to the first term, which is gonna give you n1 that is equal to 0. So you're just gonna print that in terms of n1, right? Else we're gonna have all of these inside. So if I'm wanting the first term, that's fine. The next term is working. The third term is working. The fourth term here was 2. That's correct, right? And so on, right?